Hello, grade 10s. This is the video for Unit 5, Lesson 4, and it's all about functional notation. So if you were in class and got the handouts before we left for online learning, this was the sheet that accidentally had Unit 5, Lesson 3 written on it, okay? So the sheet you're looking for is the one that says Unit 5, Lesson 3, but I asked you to scratch out that 3 and write in a 4. All right, this is the last lesson you need to learn before you can start that halfway assignment. So after this lesson and adjoining practice questions, you're going to find that Unit 5 halfway assignment that I handed out. If you did not receive it because you weren't in class, don't worry, it's still in OneNote. If you just go to the lessons, you'll see halfway assignment listed after. Okay, and a reminder that that halfway assignment is due December 18th. That's this, no, sorry, that's a lie. Not December 18th, December 20th, Sunday, December 20th. All right, and remember that these assignments are the Unit 2 final assignment and the Unit 5 final assignment are worth the same amount as exams, so they're worth a big deal. Okay, and the Unit 5 halfway assignment that you're going to hand in by this Sunday, that's the same. That's the same thing as a quiz. Okay, so I'm going to put it in your quiz category. So these assignments are important. Okay, and some of you have been taking pictures and sending the pictures via Remind. Please don't do that. Okay, please send them via email so I can read them on my computer. It's way easier for me. All right. Okay, without further ado. Functional notation. So here's a little table. And on the left-hand side, I have a column that says it's an equation with two variables. So as you can see, I have an equation. It's an equation because it has an equal sign in it. X equals 14y plus 6. It has two variables in it. The two variables are x and y. Okay. If I ask you to write an equation in functional notation, all it means is that you rewrite the equation, but beside the first variable, so beside that x, you're going to open up a bracket and write in the other variable, and then you continue on and recopy the rest. So this is the only thing that's added, and that simple little thing turns it from an equation to an equation in functional notation. So for the next one, it would be p, and then the variable in the rest of the equation is r, so it goes in brackets. And then you recopy negative 16r minus 20, and you're done. Okay, and finally, this one works the same way. F, and then the other variable is an n, so you throw it in brackets, and you recopy the rest exactly how it is. So there you go. Okay, and we're going to be using these types of functional notation equations for the examples today. So just a few notes here. The isolated variables in each equation. So the isolated variables are the ones all by themselves on the left. So x, p, and f. Okay. Those are the dependent variables. Okay, I'll explain that in a second. Okay, and then because their value depends on the value of the other variables, so the other variables are the y's, the r's, and the n's. And those are the independent variables. So I'm going to explain what that means. Okay, dependent and independent. So if, for example, in this equation up here with the x and the y, if I wanted to solve for x, like if I wanted to figure out what x actually equaled, well, then I would have to plug something in for y. All right. So say, for example, I want to replace y with number 1. So what that would look like, that would be x equals 14. I plug a y in with 1 plus 6. Well, 14 times 1 is still just 14. And then if I add 6 to it, equals 20. So I find out here that x equals 20. But x equals 20, I was only able to find that out because I plugged something in for y. So in order for me to find the value of x, I have to plug something in for y. So that's why the variable x depends on what value I throw in for y. And I can throw in whatever value I want for y. I could throw in a 1, a 2, a 3, a 4. So that's why the y is independent. I can do whatever I want with the y, but then the x depends on what y value I throw in. Okay, I hope that makes sense. Okay, So here's an equation. Here's a problem, actually. The equation V equals negative 0.08 D plus 50 represents the volume of gas, and the volume of gas is going to be represented by that V variable that we see, that guy right there, okay? It represents the volume of gas that is left in your gas tank after driving a certain distance, and the distance is used or represented with that D variable that we see right there, okay? So this equation will tell us how much gas is left in your gas tank after you drive a certain distance. Okay, so as we know, as we drive, our gas tank empties, right? The first question is to write this equation in functional notation. Easy peasy, free marks. All you do is throw that other variable, the D, beside the V in brackets, and you recopy the rest of the equation exactly how you see it. Okay? Now, this is where we actually get into the work here. The next question says, determine the value of V of 600. Okay, so I want you to look at this right here. Okay, we have V, and then in brackets, we have the D. So here, if we look here, we have a V, and then in brackets, we have the 600. So essentially, I am replacing D with 600, or I am telling you that D equals 600, or our distance is 600. So we now know that we drove the car a distance of 600. And I'm sorry, I forgot to write in the equation or in this problem here that we're in kilometers. Okay, we're in Canada, we use kilometers when we're driving. So I'm telling you that our distance is 600 kilometers, okay? And we're going to therefore determine the other variable, which is the V. So we were going to figure out how much gas is left in the car. So this is what we do. We take our functional notation, but we know that right now we're replacing the D with 600. So on the other side of the equation, that portion right there, we're also going to replace the D with 600. And we recopy the equation. Now we're going to simplify. We know that we have to multiply values together first. So negative 0.08 times 600 is negative 48. And then now we add that 50. And we are left with 2. And sorry, I forgot to write the units up here as well. When we're talking about volume of gas, we're talking about liters. Okay, that's how our gas tanks work. So we know that there's only going to be 2 liters left, and that's not a lot, right? Imagine a giant jug of milk at your house. If you buy the really big ones, those are 4 liters. So cut that in half. That's 2 liters. That's not much gas left in your gas tank. And that makes sense because we drove 600 kilometers. That's a huge distance. That's to Saskatoon and back, and then halfway to Saskatoon again, pretty much. Okay? And we're done the question. We found our answer to be 2 liters left. Okay, this one here is different. This one says determine the distance driven if V of D equals 26. So now we're looking for the distance, like our D is our question mark. How far did we drive? And then it tells us that V of D is 26. So in our functional notation equation up here, we have to replace all of VD with 26. So if you look at that equation, that functional notation up top here, the VD is the whole left side. So we are now replacing the whole left side with 26. And then we're looking for D. So we leave that D there. We don't know it, we're looking for it. So that's our setup. In a question like this, though, it's a little bit different because we have to solve for D. We have to isolate for D. Isolate D. That's why I did a review of solving equations for lesson number 1, for stuff like this. So if you did lesson 1, you know that to isolate D, we're going to minus 50 to both sides. 26 minus 50 is negative 24. That's my new left side. And then I still have this decimal with the D there, and those canceled out. Now, I have always have students here who are tempted to do this. Don't write this down. They want to go plus 0.08 on both sides. No, no, no. The negative 0.8 is multiplied to the D. So what we have to do to undo a multiplication is divide. And we divide by exactly what we want to get rid of, which is the negative 0.08. So on the left-hand side, when you do that division, sorry, I'm just looking for my answer here. You get, on the left-hand side, 300. And the two negatives cancel out. So it's 300 positive equals, and then this cancels out D. Okay, now when we're talking about distance, we know we're talking about kilometers. So put that in put your units in. So this just means that if we have 26 liters of gas left in our gas tank, we had driven about 300 kilometers. Okay. Determine how far you drove if there were 23 liters left in the gas tank after your trip. Okay, so let's figure out, what are they asking for? What are they telling us? They are telling us how many liters are left. So they are telling us our volume. Okay. And therefore that means we must be looking for distance, right? Because determine how far you drove. That's another way of saying distance. So this is a similar setup to this question here. We know what the volume is. So we know our entire left side is that 23. And then we're looking for distance. So I'm just doing a few examples here because all the examples can really be asking you the same thing, but in a different way. So I'm showing you a few of those different ways. So we are going to now solve this equation just like we did in C, minus 50, minus 50. That's a 5, not an 8. Okay, so 23 minus 50 is negative 27. Equals negative 0.0 D. Just like in the last question, we divide off that decimal. Now, on the left-hand side, when you do that division, the negatives cancel out and you get 337.5 equals, and on the right-hand side, those cancel off, so you just have D, and don't forget your units. That's distance, so it's kilometers. And therefore, if we had 23 liters left in our gas tank, that means we drove that far. All right. Last one like this. Let's see what it's asking. If you drove 425 kilometers, how many liters of gas would be left? Okay, so we know our distance. We know we drove 425. Okay, and then it says how many liters? Whoops. How many liters of gas? Well, that must mean we are looking for volume. We are looking for the volume when D is 425. Okay, so this question here is similar to B. B is the only other question here where we knew what the distance was. So this question is asking to determine the volume when your D, which is the little letter in brackets beside the V, equals 425. So on the right-hand side, we can also replace that D variable with 425. And now all we have to do is simplify this right-hand side. This just means multiplying those two out. So negative 0.08 times 425. For some reason, I don't have that number written down. Let me just do that quick. So 425 times 0.08 is 34, but it's negative 34, right? And then we add 50, negative 34 plus 50 should be 16. Let me just double check that. All right, so that equals 16. So what did we just find? We found how many liters of gas were left. So that means our unit is liters, and that's our volume after 425 kilometers in the car. Okay, I'm giving you these questions here because they're not word problems now. They're just a straight up equation or functional notation is already given, and then I just give you something that looks like this, and you got to figure out what that means. So for the function f of n equals 3n minus 10, determine f of 4. So we know that in the functional notation format right here, the letter inside the bracket is an n. So here I'm replacing n with 4. So in this equation that I give you, we are in the process of finding f when n is 4. So where you see the n on this side, you also replace it with 4. That becomes 12 minus 10, and that becomes 2, and we're done. So this function equals 2 when n is 4. That's what that means. F of -6. So now I'm going to replace that n on the right-hand side with a -6. So it's 3 times n, but that's actually -6 now minus 10. Well, 3 times -6 is -18. You take away 10 more and you get -28. So when we replace n with -6, we'll get -28. That's all that means. I wanted to do one more because I wanted to give you a fraction. So f of 1/3, I want n to be 1/3. So in the other side of the fraction, when I see n, I replace it with 1/3 and I recopy the rest. Now, don't get scared here. Fractions are fine. When you multiply fractions, you multiply the top numbers together and the bottom numbers together. So this would become 3/3. But if we were in class, I would say, but what's 3/3? And someone would hopefully say, well, it's 1. Okay. The other way you can do that is when you're multiplying and you have a 3 on top and a 3 on the bottom, they cancel out, so all that's left is the 1. So either way, you're going to get 1 as your answer, but then you minus that 10 off and you get -9. So this function equals -9 when n is 1/3. Okay, this one's a little bit different. For the function f of n equals -3n plus 6, determine n. So in this question, we were given n. All right, here we're determining n, and I give you this piece of information, f of n equals 15. So I am telling you that you're allowed to replace all of f of n with 15. And if we look at our equation here, f of n is the whole entire left side. So I'm replacing my entire left side with 15. I recopy the rest. I'm looking for n, so n stays as a variable, and now I solve. I'm going to -6 to both sides. I get 9 on the left-hand side equals -3n. That's gone. I divide off by -3 because those are multiplied together. I do the same thing on the other side. 9 divided by -3 is -3. And I get n. Okay? So what that essentially means is f of -3 equals 15. Okay, so if we were to plug -3 into this guy, we'd get 15. Okay, it's just kind of doing the same thing as we did in that previous example, but in reverse. Okay. So now for the next one, same thing, but I'm going to replace the whole left side with -20. So I have -20 on the left-hand side equaling -3n plus 6 on the right-hand side, minus 6 off to both sides. -20, take away 6 more is now -26, and that equals -3n. And then I'm going to divide off the -3, excuse me. Now 26/3 can't reduce, but you can at least cancel out those two negatives, and you should. So the answer is actually positive 26/3. All right, easy as that. And last one, I want to throw a fraction at you again. So that entire left-hand side, f of n, is going to be replaced with -1/2, and I recopy the rest of the equation, and now I solve for n. Now, if you listened to lesson 1, which I hope you did, whenever we encountered a problem with a fraction in it, I told you to multiply every term by the common denominator. Here, there's only one denominator, and it's 2. So that's easy enough to figure out. I'm going to multiply every term by 2. You can't just multiply the fraction by 2. That's called being unfair, and you would wreck the equation. An equation needs balance. So what we do to one term, we have to do to all of the terms to keep things nice and balanced and fair. So on the left-hand side, when you have a 2 up top and a 2 down low, they cancel. And all you're left on the left-hand side is a -1. Then, right here, nothing cancels because there's no fraction, right? That's just a 1 on the bottom. So you just go 2 times -3n is -6n, and then 2 times 6 is 12. I'm going to minus, whoops, I got ahead of myself, whoops. I'm going to minus 12 to both sides. So on the left-hand side, I now have -13 equaling -6n. Those canceled. I divide off by -6. That fraction cannot reduce, but I could at least cancel out the negatives. And there is your final answer. Okay, so in your practice questions, just make sure you're looking closely at what it's actually asking for. Is it asking for you to find n? Or is it asking you to plug something in for n? Okay, there's your practice questions, and once you feel confident with this, you can go tackle the Unit 5 halfway assignment. Email me or message me with questions if you need. Good luck.